Take a look at what we're doing today. All right, so today it's still going to be the same type of structure, whether or not you're at home or you're in school, okay? So we are at the Hangout or you're in class. Then you're going to submit your attendance. So for the in-person kids, you do not need to submit Schoology attendance anymore unless you truly want to, because your teachers will just take attendance for you, okay? But if for some reason you're at home and you're an in-person kid, then you still have to submit attendance, okay? So whenever you're at home, submit attendance. But if you're at school, then you don't need to submit attendance, okay? So today, what you're gonna do after when asynchronous starts is you're gonna watch the 3.1 video notes, okay? And then you must submit these notes today for a daily grade, all right? And then questions, comments, please email me, or you can ask me in person, or I don't know, email me, of course, that works too. So I want to clarify something because I looked at your notes that you submitted last Thursday, and I feel like maybe I wasn't clear, okay? So when you have notes, like you are literally writing everything the teacher is writing down. So a lot of you just wrote the answers. Like to your notes, you just wrote answer, 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 answer. And that's not enough, okay? So I need you to show all of your work. So when this was me teaching, well, there's not too much work to show today, but like every little thing the teacher is writing, please make sure you're also writing it down. So maybe what I can do is, sorry, I'm going to throw someone on the spot. I'm going to throw someone, a 7th grader from, I'm going to throw a 7th grader from my other period. So maybe you guys don't know him or her. I don't even know who, but I just kind of want to show you. And I know that on Kami, it's hard, but if you're an in-person kid, I will have copies for you so you can just take a picture of everything. So it's not so difficult if you're in person, but I'm sorry, if you're not in person then, and you're using Kami, then it is going to be a little bit harder for you, okay? Let me see if I can remember. Let's see. Okay, so we had maybe this person. Okay, did she write it or did she type it? Let's see. So when she submitted her notes, come on. Okay, I know it's sideways, but that's okay. I can read sideways. Okay, so she wrote it though. That's okay, I'll show you. Notice how she wrote everything the teacher wrote down. Come on. Okay, so like you see all this work here. Some of you just wrote answer, 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 answer. Okay, so that technically is going to give you a 0 in the future. But do you see how she like showed her work? She wrote everything the teacher wrote down. Let me try to find another one. I feel like there was one where it was written in Kami and it looked like a lot of hard work, but it's Kami and it's online. So if you are able to just write it down, even on a separate sheet of lined paper, then that's fine. I guess this is more geared towards the online kids, but if you're in person, you still have to write everything the teacher, so all your work down. Come on. Oh my gosh. Thank you for being patient. Okay, so okay, do you see all this work right here? Like she typed it all out on Kami, and that's great. And it takes a lot of work, I know, and a lot of time on Kami to do that. So if you want to do it on a separate sheet of paper, online kids, you can do that. Or if you have a printer at home. But really, guys, in the future, something like this, you have to show your work, okay? So I graded your things on Schoology, and you should be able to see your grade from last Thursday. And a lot of them were 0s. And the reason why was because you didn't show your work. So I'm actually not going to take last Thursday's for a grade because there were a lot of 0s. Okay, so starting from today, when you submit your notes, during the time you have to submit your notes, just make sure that you are actually showing all your work. Okay, all right. So we are starting a brand new unit today. We're talking more about graphs. So let's go ahead and do that. Okay. What do you say? Oh, so I think I'm muted. Thank you, Rowan. I think I'm muted only on one. So this one, am I muted? This one? No, I'm not muted on that one. Okay. So I'm just muted on my other one because I'm open on two, because if I'm recording, then I can't, yeah. Anyway, so I'm not muted on this one. I'm good. Thank you, though. I'm probably going to be muted at some point in the year. So please tell me if I'm doing something wrong. All right. So all of you have this paper in front of you. If you are an online kid, then go ahead and just follow along. I also have it attached on Schoology, but I don't know if you printed it out. Maybe you want to hurry print it out right now. It's your call, okay? But if you are able to write it down, please write it down with me, okay? So this is what chapter 3 is going to look like, okay? So if we're going to talk about something called functions. So a function, a definition of a function is when, so write this down, please, when your x's do not repeat. So there was a rule you learned last year about functions, and the definition of a function is when your x's do not repeat. And then also, you know that something is a function when it passes the vertical line test. So when it passes a vertical line test, that's also a function. And we'll talk about that in a minute, but let's just write the definitions first. Okay, so I have a table. I want to see if something's a function, yes, no, and then I want to write why. So the definition of function is when your x's do not repeat. So what you can do is just look at your x's. So I have a bunch of y's. I'm just going to cross those out because I don't care. All I care about are the x's. So look at your x's. -1, 0, 1, 2. Did any of them repeat?
No.
No. So then is it a function? Yes, right? Since these x numbers did not repeat, then yes, it is a function. So yes, why? Because the x's don't repeat. Okay, let's take a look at the next one. So now I have points. I'm still going to use the same rule. When your x's do not repeat. Does anyone know, like if I have a point, does it go xy or yx? Xy. So it goes xy, xy, xy. Whenever I have a point, it's always the x's first and then the y's. So what I'm going to do is I'm actually going to cross out the y, cross out the y, cross out the y, because I don't care about them. I just care about the x's. So I have 3, 7, 3. Did my x's repeat? Yes. So is it a function? No, it's not, because my x's did repeat. So no, it's not a function because the x's repeat. Okay, next one. Now I have a picture of a graph. So you can say like, oh, do x's repeat, yes or no? But you can also say when it passes a vertical line test. So what that means is vertical lines go straight up and down. What I normally do is I just imagine like I have like, I don't know, my pen or something, and I just go back and forth, and does it pass the test? So imagine if I were to draw like a bunch of vertical lines. Does my vertical line ever touch my graph in more than one spot? No, right? It touches one time here, one time here, one time here, one time here, one time here. So since it only touches it in one spot for one line, then what do you think? Is this a function, yes or no? Yes, so I would say yes, because it passes the vertical line test. Okay. Next one. Let's take a look at this one. So take a vertical line and go back and forth, or you can like just draw one, sketch it out. So what do you guys think? Does this pass the vertical line test?
No.
No. Do you see how like this line, it touches here and here? I mean, I don't even care about the other ones because as long as it touches in two spots in just one of the lines, then that did not pass the vertical line test. So I would say, no, this is not a function because it didn't pass the vertical line test. Okay, next one. Now I have a bunch of dots. That's okay. I just have dots. What do you think? Do you think this one passes the vertical line test?
No.
No. Do you see how right here it touches it in two spots? Like it touches it in one spot for all the other places, but it touched it in two spots right here. So I would say no. Or you can say X's repeat. You can say doesn't pass vertical line test, whatever you want to do, whatever you want to say. Okay. That's the easy stuff. Let's get to the really confusing part now, okay? There's something called domain and range. Okay, the domain is going to be the X values. So when you think domain, you always just have to think X. That's just something you have to memorize. The range then is going to be the Y values. So when you think range, you always got to think Y. So if I have a group of points here and I want to figure out what's the domain, I'm just going to write D for domain. I just have a list of points. Well, I don't know what are my X values, but I know that in a point I have X, Y, X, Y, X, Y, X, Y. So aren't my X values, let's see. I have a 7, a 5. Oh, I have another 7. That's okay. I'm just not going to repeat it. Okay. I don't need to write it twice. And then I have a 9. I'm writing these really weird like squiggly brackets because that's technically how you're supposed to write it. But if you want to, you can just write normal parentheses and that's fine. Okay, one last thing for domain. You technically are supposed to put it in order from smallest to largest. So you have 5 and then 7 and then 9. So really, that would be your domain.
Miss Regina?
Yes.
How are you supposed to write those squiggly brackets we can't see?
Okay, so squiggly bracket, let me write it bigger. It's like, it kind of just looks like this.
Oh, so we can't see it.
You can't see.
No.
Am I? Oh no, I wasn't presenting. Okay. I'm so sorry, guys. Thank you, Ryan, for speaking up. Okay, hold on. Let me do it on my other one. Okay. Let me turn it off here. Okay. Can you guys see now?
Yeah.
Okay. I'm sorry about that. Sorry, guys. Okay, remember, I have this video recorded, and so you can just watch the first 5 minutes of it, what you missed, because I forgot to hit present. I'm so sorry. Okay.
It's okay.
All right. So now let's take a look at the range, okay? So we said that the range is Y. So if my range is Y, then I'm only looking at the Y's. So can someone raise their hand if they're in here and tell us what you think maybe the range would be? Jack, what do you think?
3, 6, 9, and 12.
Just the Y. So yeah, exactly. Perfect. 3, 6, 9, 12. And the good thing is they already wrote it in order from smallest to largest. So I really don't have to reshuffle it. So that's the range. Okay. Let's take a look at this one now. Now I have a picture of a graph. So let's find the domain. So the domain, remember, are the X's. Okay. So I just have dots. So here are my X's. My X's, remember, are always on the bottom. So look at where your dots line up. This dot goes to the 0. Go to the next one. This dot goes to 1. This dot goes to 2. Oh, 2 of them go to 2. Should I write them both down or should I just write it once? Once is fine. You really don't have to repeat it. And then this one goes to the 3. That's your domain. So my range, it's kind of harder to visualize. Okay, so range is your y, right? This is your y right here. So where do your dots go? So start from the bottom. This one goes to the 1. These two go to 2, but that's okay. Don't repeat them. These go to 3, and that's your range. So notice how your domain has 4 numbers and your range has 3 numbers. That's okay. It doesn't matter. Okay, you can have a different set of numbers. It totally doesn't matter. Yes. You don't write 0 because you see how for the y's there were no dots that ended up on the 0? Okay. All right, backside. Now it gets even more complicated because you don't have dots. You have dots that are connected by lines or curves. So let's look at the domain. Okay, so we know the domain is the x's, right? So look at your x. X goes from left to right. So do you see how if it's all connected and not dots, we're going to kind of write it like a compound inequality. You're going to have x in the center. Your inequalities, your alligators always eat to the right. Okay, so the far left, you see how this picture goes all the way to -3? So it starts at -3, but then it goes all the way to +3. So that's your domain. Normally what I like to do, guys, is if possible, I'll like draw a box around my picture. So I know the x's, it goes from left to right. And then my range, so my range is y, so I write y in the center now. My alligators always eat to the right. And then y goes up and down, right? So how far low do I go to how far high do I go? So how far low did I get to? The 0, right? It hits the 0. And then how high did my picture go? To the 3. Okay, I forgot something for the domain and the range. Do you guys know what I forgot? So, no, you don't need squiggly. Well, yeah, I guess you could have squiggly lines. Okay, there's something else I forgot. Does it include the -3 and the +3? Are those numbers included? Yes. Rowan? Yeah, go for it. So do you see how, like, there's not open circles here? It does include it because they're closed circles. So I should have a line underneath and a line underneath. So for this one, same thing. It included the 0. Even though there's no dot on there, it's a solid line. So it included the 0, and it did include the 3. So I should have a line underneath these as well. Okay. Let's try this one. So my domain. So do you see how, first of all, I'm not listing it off as a group of numbers? Like I'm not listing it off like this because the picture is not just dots. It's not just separate points. They're all connected with a line. So that's why whenever I have something like this where it's all connected with a line, I have X in the center. And it looks like there's no open circles. So that's why I always have the line underneath. Same thing for the range. Range is Y, so I have Y in the center. There's no open dots anywhere, so I have to always put the lines underneath. Okay, so X is domain. So think about going left and right. How far left does your picture travel? So you see how it goes all the way to the -4? So it goes from -4. How far to the right does it travel? Well, yes, it kind of goes to 1.5 to 2, but you see how there's arrows there? So doesn't it technically mean that it keeps on going on and on and on and on and on and on and on? So really it goes to infinity. Now here's the rule. If you have infinity on any of the sides, just cross it out. You're not supposed to write infinity. If you have infinity on any of the sides, you just cross it out. So really, your domain is x is greater than or equal to -4. Okay, your range is x and y. So how far, range is like up and down. How far low did you go? -infinity. And then how far high do you go? Positive infinity, because it keeps on going up, 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 up. Okay, so if you have infinity on both sides, that just means it's every single possible number in the whole world. So if you have every single possible number in the whole world, what do you technically write then? All real numbers. Every single number in the whole world is all real numbers. So here's the rule. If you have infinities on both sides, it's all real numbers. If you have infinity on one side, you just cross it out and then you just rewrite it. Okay, one final example. Let's do this one. So domain, range. So domain, is it x or y? X. Range, is it x or y? Y. Now notice how they're all connected with a line, 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 line. It's not separate dots, so I don't write separate numbers. So when they're all connected with a line, you write the inequality signs. When you have a picture with just a dot, 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 then you just write number, 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 number. They're closed. They look, well, let's just be clear. They're closed right now. Let's just close them. So since they're closed circles, you write lines underneath all the inequalities. Okay, so domain is x's. How far to the left? How far to the right do you go? So how far to the left do you think you go? -3. How far to the right do you go? 2. Okay, range is always a little bit harder. Range is y, y is up and down. So how far down do you go? You see right here, it goes to the -5. How far high do you go? So everyone always gets confused because they want to say the dot. No, no, it goes this high. So it does go to the 2. You're right. So go as high as like the actual picture, not the dots. And so that's your domain and range. I know that takes some getting used to. All right, so one final thing. The domain and range look like numbers, like parentheses, and you're going to have numbers in there when the graph is just points. So when you have a picture like this, dot, 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 your domain and range are just a list of numbers, like 1, 3, 7, whatever. But the domain and range look like this, where you have a number and then an inequality and then the x or y and then another number. It looks like that when the graph has connected points. So when it looks like you see how they're all connected. So if they're connected by points, then you write it as an inequality like this. But if it's a separate dot, then you just write number, 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 number. Okay. Are there any questions? So what you're going to do today is you're going to watch a video, okay? And then